Here we have another water pressure problem. And so we're given this water storage tank, and we are asked what the forces are acting on each of these segments, right? AB, BC, CD, and DE. And so what we can do is we can go through and we can just figure out what the pressure is at all these spots, right? We can say, let's do that in red. Right, we can find what the pressure is here, what the pressure is there, 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 and there, and we know that the change in pressure between those points has to be linear because we know that P is equal to gamma times D. All right, so let's start at the top. Let's say my PA, well, that's equal to 0. That's easy. It's at the surface. We're doing gauge pressure. PB, now I'm 4 meters deep, so it'll be 4 meters times gamma. Maybe we'll just leave it as that. PC is then what? It's all the way down here. So it doesn't matter that it's not like vertically under this, it's still 4 meters deep, right? If I look here, then that's 8 meters, right? 4 plus 4, so 8 meters. Times gamma. PD. Now it doesn't change, right? This point is also 8 meters deep. So the pressure is the same at C and at D. And then PE is then, that was 8 meters, was this point, plus 3 meters would be 11 meters times gamma. And now we can go through and look at each of those segments and figure out what the pressure profile is. Once we have the pressure profile, we of course get the pressure prism, and from that the total pressure. All right, so if we look at AB, draw ourselves the segment, right? So this would be A, this would be B. Now we already figured out that the pressure at A is 0, and we said that the pressure down here was 4 meters times gamma. We know it's a linear change in between, so we get a triangle. We know that this height here is 4 meters. So we can find that the pressure acting on segment AB, right? So all we have to do is do the area here and multiply it by the depth. So the area of this is just 1/2 times 4 meters times gamma, right? That's the height of this triangle. And then the base is also 4 meters. And then let's not forget that we're doing, we have a 10 meter width. It's popped out in there and there. So times 10 meters. That gives me, if you plug all this in, I guess, right? Maybe you'll put up here. Well, it says it up there, but nonetheless. So with lots of scribbles, with gamma equal to 9.81 kilonewton per cubic meters. Right, so if we plug all these numbers in, I get 784.8 kilonewtons. So that would be the pressure at A. Now at B, let's see what we get for a B to C. That's the one that looks a little tricky because it is sloped. B to C. All right, so we have a sloped one. Now we know what the pressures are here and here, and we know that the force always acts perpendicular, or the pressure always acts perpendicular, right? So we have here, we have the same pressure at B, so 4 meters times gamma, and here we have a higher value, and we know it's a linear change in between. So we get more or less a trapezoid. So this was 8 meters. And now what is the length of our segment here? Well, we know if we sketch in a little triangle, then we know that this is 3 meters, this is 4 meters, so that's of course 5 meters. So we can just get the area of this trapezoid and multiply it by the width, and we're good. So this would be PBC. Now the area of a trapezoid, right? So it'd be 4 meters times gamma plus 8 meters times gamma divided by 2 times the length, 5 meters, and then the whole thing times 10 meters. And that then gives me 2,943 kilonewton. Right, you can see it's getting higher and higher forces as we're going deeper, because of course we're getting higher and higher pressures. Then our next one would be CD. Let's look at our sketch. Where is CD? CD is this flat one right here. Well, this one's super easy. Pressure doesn't change. So let's do our part here. How long is that one? That's 4 meters. And we have our pressure acting it, both sides the same. Oh, you know what? I should put some, I forgot to name the points here, right? So this would be B and C, C and D, just to be complete. Now, it might not look as if it's a straight line, but it's supposed to be a straight line, and it's 8 meters times gamma, 8 meters times gamma. That means our PCD is then equal to what? Well, we need the area of that rectangle. So that's easy to do. The area of the rectangle is just 8 meters times gamma, and not plus, times the length, so 4 meters, and then times the width, 10 meters. And that gives me then, that gives me 3,139.2 kilonewton. All right, so that gives us CD, so we're left with DE. It's just a straight one down. So that would be DE. A straight wall down. Oops, that's not even close to being a straight wall. There, that looks a little nicer. We know this is D, this is E. And how high was that wall segment? 3 meters. So from here to there, 3 meters. And now we know what our pressures are, right? We calculated them up here. We said at the start, at D it's 8, at E it's 11. So we get another trapezoid, right? So this is 8, this is 11. So again, all we have to do is find the area of this trapezoid, and we're good. That's a PDE is then equal to, well, let's note this in. This was 8 meters times gamma. This was 11 meters times gamma, which then gives us another trapezoid. So it'd be 8 meters times gamma plus 11 meters times gamma divided by 2. This time the length is 3 and the width of course is still 10. And that gives me 2,795.85 kilonewton. And with that, you have all four forces. All right, so we can say we have a force acting somewhere here, somewhere there, and somewhere there. Right? Those were the four forces that we just calculated.